Guys, so today we're going to discuss measurement in chemistry. Measurement in chemistry is like measurement in all science. We want our measurements to be both accurate and precise. Many of you may feel that those two words mean the same thing, but they really don't. Accuracy is how correct your measurement is. So, is your measurement close to the actual amount of material that is present? If so, if your measurement is correct, then it's accurate. Precision is how small the increments are on the tool you're using. So for example, I have two different graduated cylinders here. So here I have a graduated cylinder that has a marking on it every 10 milliliters. So those markings that are large and marked with numbers are called major divisions. I have a major division on this particular instrument every 10 milliliters. And then I see minor divisions, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them in between, marking each milliliter. So I have a major division every 10 milliliters, and I have a minor division every milliliter on this particular piece of equipment. Here's another graduated cylinder. It's smaller, and if I look at the major divisions, it's not marked every 10 milliliters. This particular graduated cylinder is marked every single milliliter. There are still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minor divisions in between each major division on this particular graduated cylinder, which means I have a marking every 10th of a milliliter. So this graduated cylinder had a marking every single milliliter. This particular instrument has a marking every 10th of a milliliter. That makes this graduated cylinder more precise than the larger graduated cylinder. So then how do we take measurements on these graduated cylinders? If I look at this particular graduated cylinder, and when I hold it, I want to make sure that it's level. In fact, I probably need to set this down. And I'm going to look at the meniscus in this graduated cylinder. So the liquid inside the graduated cylinder is going to be curved slightly at the top. We're going to look at the bottom of that curve in order to read the graduated cylinder. And if I look at this graduated cylinder, it looks to be between 60 and 70. And if I count those minor divisions from 60, I see 61, 62, 63, 64, 65, 66, 67. And it's somewhere sort of between 67 and 68 on this particular graduated cylinder. So it's between 67 and 68. Okay, so what we're going to do is, because this graduated cylinder has a marking every milliliter, I said it was between 67 and 68. I know that this graduated cylinder has a marking every single milliliter. What I can do is I can estimate the next place. So I'm going to estimate one more place value past my minor division markings. So since my minor division markings were in the last whole number place, I'm going to estimate the 10th place. And since it was between 67 and 68, a good estimate would be 67.5. So I'm going to estimate that last decimal place in my measurement. For this other graduated cylinder, if I look at it, it's between 9 and 10. And if I look at the minor divisions and count from 9, I go 1, 2, 3, 4, 5, 6, 7, and it's almost right on the 7th minor division between 9 and 10. So this graduated cylinder has markings every single milliliter, major markings, and it also has markings every 10th of a milliliter. I'm going to estimate one more place value after that in my measurement. So I knew that this was 9 milliliters. It was between 9 and 10. And again, it was right on that 7th minor division between 9 and 10. So I'm going to say that it was 9.70 milliliters because it was right on that 7th minor division between 9 and 10. So it's very important when we're taking measurements that we look at the piece of equipment we have and we look at the precision of that instrument. We're going to read the instrument, and then whatever place value is the minor marking division on that instrument, we're going to estimate one more place value after that. We can see how this helped our measurement be more accurate, because when I looked at the graduated cylinder for this first measurement, I saw that the liquid, the meniscus level, was between 67 and 68. And so I was able to estimate a value that's between 67 and 68, which brings my measurement closer to the actual amount of liquid that's in that graduated cylinder. So this measurement is both accurate and has a degree of precision. This second measurement that I made, we looked at the graduated cylinder. We knew that it was between 9 and 10. It was on the 7th hatch mark, right? The 7th minor division between 9 and 10. And it was right on that minor division line. So I put it right on the money, 0.0. So make sure that you guys always read the instruments correctly. Look at the bottom of the meniscus. Look at the major and minor divisions that are on your instrument, and then always estimate one more place value past that minor division in order to get both an accurate and precise measurement.